In this problem, we need to find a confidence interval for the mean value of the differences for the population of all the pairs of data, where the data come from Friday the 6th and Friday the 13th, and we're looking at the numbers of hospital admissions resulting from motor vehicle crashes. We want to see if there's a difference there. So I'm going to start by writing the null and alternative hypotheses. So my null hypothesis is that the mean of the differences is equal to 0. The alternative hypothesis is that the mean of the differences is not equal to 0. So this is a two-tail test. And then I'm going to put my data into the calculator. So L1 is the data from Friday the 6th, and L2 is the data from Friday the 13th. And in the problem, they tell you to make the individual differences defined as the number of hospital admissions on Friday the 6th minus the number on Friday the 13th. And that way we keep the values correct for this confidence interval that we're creating. I could subtract it the other way, but my MATLAB won't accept that as a correct answer, so that's the problem with that. So you have to follow their directions on how to subtract. So L3 is going to be L1 minus L2, and you can actually put that into the calculator, put the data from Friday the 6th into L1, Friday the 13th into L2, and then when you go up to the top of L3, you type in L1 minus L2, and that'll fill in the differences. But I can also just go ahead and subtract them. It's really easy to do this subtraction. So I just take each pair, 4 minus 14 gives me negative 10, and so on, and I have my 5 values for L3. So I can just go ahead and put those 5 values into L3 in the calculator, and that'll work just fine. So now I'm ready to find my confidence interval. So I'm going to do a t interval. My input is data. My list is L3, or if you just found the differences yourself and put it into L1, just make that L1. The frequency is 1, and the confidence level is 95%. They tell us in the problem to find a 95% confidence interval. So we've got 95% there, and we calculate, and the results are, we get a confidence interval from negative 10.04 to negative 3.959, and then we need to round this to negative 3.96, and that's our final answer to this problem.